So this video is going to wrap up our discussion on matrices for now. We'll revisit it in a later chapter, but for right now, the last concept I want to get across is just to introduce the idea of an inverse matrix. So I have two notes right here, and I'm actually going to talk about the second one, the purple one, first. We've never talked about dividing two matrices. That's because it's actually not possible to divide matrices. You will never, ever, ever do matrix A divided by matrix B. It's just we don't have it. You can't do it. But sometimes you may want to cancel out a matrix being multiplied. And the way we do that is by multiplying by the inverse. So the two matrices are inverses of each other if their product is the identity. And this is getting into more in-depth math that I just want to have a very brief, I'm just giving you a very brief overview. This will not be a bad topic here because I'm not going to go into the details. It can be kind of tedious to calculate inverse matrices, and it's something that I'm just not interested in doing with you guys right now. But I do want you guys to be able to tell me if two matrices are inverses. So I would not ask you guys to figure out, if I just gave you a matrix, I would never be like, hey, find the inverse. That's not what we're not going to cover it in our unit right here. But what I might ask you to do is give you two matrices and say, hey, are those two inverses? There's a difference there in the question. To decide if they are inverses, recall on the last slide, two matrices are inverses if you multiply them and you get the identity. So all we're going to do to test if these two guys are inverses is we're going to multiply them together, and we're going to see if we get that 1, 0, 0, 1, the identity matrix. And if you do your karate chop here, for the first one I have 2 times 2 is 4, I have 3 times negative 1 is negative 3, 4 minus 3 is a 1 there. If I multiply those I get 2 and then negative 2, those cancel. If I multiply those I get negative 6 and positive 6, they cancel. And if I do my last chop here, negative 3 and 4 is a 1. So I multiplied those two matrices together, and it turns out I got the identity here. This is I. That means that yes, the matrices are inverses. If I would have multiplied those two guys together and gotten anything else in the world there, any different numbers, it's not the inverse of each other. They're not inverses. But because they kind of multiplied and gave us just this identity here, they're inverses. So the way I will refer to that, sometimes you'll call, you remember we use capital letters for matrices? If this is matrix A right here, the way we show that it's an inverse, these are sideways equal signs, by the way. What we do is we put A, and the inverse symbol is like a little, almost looks like a negative 1 exponents. That means A inverse, so the inverse of A.